Exciting one for you here today, guys. We are in California, the Sunshine State, and we're going to take a behind the scenes look at Fujikura's office and see how the sausage is made. We've also got something very special for you in this video, so make sure you stay tuned to find out what that is. One of you will be very happy. Let's head on in, meet the team, and see what goes into making some of the products.
Hi, Matt.
How you doing?
Good, thank you.
Good to see you.
Welcome to Carlsbad.
Thank you.
Yes,
Nice and sunny out here.
Yes, that'll have a good day for you for sure. So Fujikura Composite America has been in San Diego since 1994. We've moved a couple of different buildings, but we're here in Carlsbad now, and I'll show you just a quick brief timeline of our company here in the States. We've got a few key highlights here. We developed some key R&D technology in our Enzo system, which you'll learn a little bit more about today. All the way up until VelaCore, which you're familiar about, and again, we'll learn more about today, both in our Ventus and Axiom products. We'll show you through the back.
Awesome.
Start it up.
Our man Spencer here can take over for us.
How are we doing, sir? You're going to be showing us around, are you?
I am, apparently. Do you want to see how shafts are made?
Yeah, let's go and see how the sausage is made. So we've come inside here, Spence, and now we're going to see how everything is made. I don't think a lot of people would probably understand the process of how a graphite shaft is made.
Yeah, it's a little different than most people sort of anticipate. But what's cool about this is, at our facility here in Carlsbad, this is an exact replica of what our factories are set up, the exact same way. So we can prototype a shaft from ideation, design sheet, all the way to completed graphics. So we have a good handle on, if we can make it here, we know it can be made in mass scale at the factory. Yeah. So we don't do a lot of production out of this facility. It's more R&D based, but we can if we need to. There's been instances in the past where we need to accelerate some parts, maybe for the tour, something like that, and we can make a full finished part to get out to the tour, you know, within a week. So I'm going to show you sort of start to finish how this works. My question for you is, have you ever seen how this works?
No.
Any clue? Right,
no,
so we're just going to start from scratch.
I sort of understand the process, but not fully.
Okay.
Yeah, I thought it was just like pure factory, just and it was rolled and I
There's some of that. There's some of that. It's what's cool about what we do is a lot of the techniques, even in our factory, are very hand applied. Yeah. There's some things that are more automated, less automated, but you'll see basically how we roll a shaft, how we test a shaft for durability, and all the in-betweens.
Let's have a look.
Cool.
I'm excited this.
So essentially everything's going to start right here. This is a temperature-controlled freezer, and this houses our carbon fiber material. Every golf shaft that we make essentially starts out looking like a giant roll of carbon fabric material. So this is pre-preg material, meaning it's carbon fiber that has resin implanted into it. Yeah. Now we keep this at a constant temperature because we want to make sure it extends the life of the product, and also we don't want the resin to get too hot. We want to keep it as it is when it comes from the factory to us. Now what we'll do is we'll take this out, and you'll see that each one is listed as different types of material. A design sheet will come back to our team here. They will know the exact combinations of materials to pull. Yeah. So it depends on the complexity of the shafts. Some shafts you can see with only a couple types of material. Yeah. Some you can see with up to 3, 4, 5, 6, 7 types of material. Just depends on the complexity of the shaft and what we're trying to do.
So it's not just all one sheet then, it's multiple.
Correct. And then what we do is we work in plies and layers. So that's where we start to combine different materials in a shaft. What that enables us to do is we can alter torque, bending stiffness, stability in certain parts of the shaft. So we're really dialing in performance from the get-go, all from the materials that we select.
That's insane.
So we'll pull what we need to pull, we'll lay it out here on this table, we'll kind of let it dry out a little bit. We want the material to come to a malleable temperature, right? So I told you before, we don't want that resin to get too hot. Yeah. Right, we don't, but we want to keep it pliable. We don't want it too cool and too brittle, so we'll let it lay out for a bit. Now what will happen next is a design sheet will come back to our technician. You'll see that design sheet on that computer screen right there, and you'll see that we've got a sheet laid out ready to cut. That is a laser guided cutting machine, and it's going to cut out all the corresponding flags and layers that we need to roll a golf shaft. So the first two steps are identify the material, pull it, and cut it. All right, so now after we've cut the material, and we have all the plies and layers that we need, what we're gonna do is select a mandrel. A mandrel is a big steel rod that we're going to roll all this graphite material onto. Now every mandrel is a little bit different. We have different mandrels for different types of products. They have different taper rates. We have different ones for irons, hybrids, woods, obviously. So Kevin's gonna get his design sheet here. He's going to lay out all the plies that he needs. He's gonna select the right mandrel. You'll see that on each one of these mandrels, there's a little bit of a number, right? There's a 2, there's a 1. It's what's called clocking locations. That tells him exactly which location of the mandrel to apply this material. So he's going to hand press it down. Once he gets it started on the shaft, you'll see he kind of gets a good layer, a little bit of adhesion to it. He's going to take it to the pressurized table behind him. What that's going to do is adhere that layer to the mandrel. It's going to take out any air pockets, any inconsistencies, and make sure it's a very tight application. Now he's going to do this one layer at a time to build out the entire golf shaft. Checks the clocking location, checks the material location, starts the process, pressure rolls all the way through. The more complex the shaft, the more layers we'll have, and the more complex the rolling process is. So if you look at a product even like, I'll use Axiom irons as an example.
Yeah.
Very delicate process to roll. The mandrel is very accelerated taper, it's very thin at the tip, and you're using 125 grams of just carbon graphite material.
Yeah.
So it's a very delicate rolling process. So that's why a lot of what we do is done by hand. It actually does require some care and some gentle touch to it.
Unreal.
Yeah, pretty wild, isn't it?
Yeah, and that's going to be a shaft in like, in the space of 5 minutes. You'll do that and then it'll be the tube that essentially is a graphite
So you're exactly
shaft.
right. Now once Kevin finishes that, we're going to take it to this machine right behind you, and essentially we're going to wrap it. He's going to show you how he does that. What we're going to do is, this is the final stage before we take it and place it into the oven to cure.
Yeah.
That's when we want resin to get hot, cure, and adhere. So what he's going to do is he's going to do a cellophane wrap around the top. This is totally sacrificial. It's going to come off. It's just that final step to get any air pockets, any inconsistencies out before we cure the material into a cylinder shape. That's what you get. So you can feel that texture on there. That's all the cellophane wrap. And this will all come off.
What this, right, okay.
That'll all get ground off.
Yeah.
So these are sort of like sacrificial layers that we're doing to create a more consistent product, but we know that in grinding and prepping, eventually that'll come off. Now after this, he's gonna hang it in the oven to cure. We cure these at specific temperatures and timetables, depending on what we're doing. There's a big hanging oven. You can see his earlier
Feel the
samples
heat
in
off
there.
that, can't you?
Yeah, right?
So how long will he sit in the oven for?
Depends. Yeah.
75. For every single shaft, is that?
It'll vary, but depending on thickness.
Yeah.
Right.
So we've cured this, right? It's
Yeah.
all good to go. It's encased in cellophane. It's on the mandrel, but in order to make a graphite tube, we have to get the mandrel out.
Ooh.
This is what's going to happen on this machine right behind you. It's a very intimidating machine, kind of looks like a death clamp. Essentially what's going to happen is he is going to clamp down the mandrels,
Yeah,
and that
and then-
machine is going to extract it out. So
Right.
he'll show you how that works.
Oh, wow.
What you're left with is an empty graphite tube. And that is how you make a golf shaft. Pretty wild, isn't it?
Yeah. From pulling the pieces of graphite out of the freezer to here, how long is that process?
It depends. Generally what we do is we are always cutting and we're always rolling. Never two projects at the same time. So project A will be getting cut while he's working on project B. Project A will move over to be rolled the next day.
Yeah.
The longest timetables and lead tables we have is curing and drying. We
Yeah.
gotta let the stuff set
Yeah,
up.
yeah.
But we can move pretty quickly, as you can see. I mean, we can turn out an entire finished prototype start to finish in a week. And that's everything from selecting materials, cutting materials, rolling, paint, prep, graphics, ship it out the door, all good to go. So we can turn things pretty quickly for a small sort of facility, right?
Yeah.
And like I said, this is just a mimic of our full-size facility. The difference is on their end, instead of having one Kevin, they've got 4. Right?
Yeah.
But everything is the exact same process.
Yeah.
So it shows us that exactly what we design, exactly what we can do, can be replicated at full scale in production.
So now the shaft's been made, Spence, what makes it look so pretty.
So one of the cool things that we can do at this facility that makes us a bit unique is that we can prototype a shaft from ideation all the way to completion. And as you just alluded to, completion does include final paint and graphics. So we do have a paint and graphic room here at our facility in Carlsbad. What I want to show you is how we paint a golf shaft, how we apply a decal to a golf shaft, and we'll even show you a little cool customization trick at the very end as well.
Sounds good. Let's
Sounds
get
good. Let's
stuck
do it.
in. I'm excited about this
All right.
bit. Even when you come through, a few little things catch your eye. Are these just all like test ones, like we're just
stuff
playing
that we've
around?
done. We've looked at limited edition stuff, or really it's just a test to make sure that the etching machine can do what we need it to do. All right.
This is where the magic happens.
This is it, yeah. So this is our man Dre. Dre's been doing this for the better part of 2 decades, so he's got it down pretty pat. When we talk about applying paint to a shaft, there's really 2 ways that we can do it. We can do what's called a spray, which is exactly like what it sounds. You're spray applying paint.
Yeah.
Well, the other thing we can do is called a pull or a squeegee. That's what I'm going to show you today. We do some spray fades and things like that with some of our products. You'll notice it in our TR line. You'll start to see some spray fades there. Some of the Japan product, the speeder line, does that fade as well. But what Dre's going to show you is how we basically apply a solid color to a shaft.
Yeah.
So he's going to start with some shafts that have been prepped with a base coat,
Yeah.
and then he's going to show you kind of how he does the final coat. There's a lot of simplicity and artistry kind of mixed together.
Yeah.
So Dre will get set up and we'll show you how to do it. Cozy.
That's it.
That's it.
Did someone just come up with that system?
You know what? I've been doing this since, man, 96, and this has been squeegee variations of how this pot is formulated. It's
Yeah.
changed, but this right here is pretty much at least 95% of golf shafts done this way.
Done that way?
It's because you could do quite a bit, and then you don't need the respirator. You have all the VOCs is going to be heavier than air.
Yeah.
So you don't need the heavy aspirator that you're going to spray.
Yeah.
You get great finishes, quick.
Yeah.
I mean, a person can be doing this in production, easily do 1,000 in an 8-hour shift.
What?
So, because you can do about 100, 150 an hour. So,
Oh my gosh.
it just depends on the painter. So,
They look immaculate as well.
Okay, so Dre showed you how we paint it, right? So the next part after paint, cure, all those things, we're going to apply our decal to it. So this is a heat transfer decal. Dre's going to show you basically how it works, but we're going to start with a raw, blacked out, painted iron shaft, and we're going to apply an Axiom decal on there for you.
Nice.
He'll kind of walk you through the ins and outs of how it works, and you'll get to see basically that's how we finish off a shaft.
this is safety. So that's why if you get too close, shut it off. So,
Oh wow. That's amazing. And would you just have like different rolls if it was a different something
we get it sent out to the factory, and then basically what they're doing is screen printing onto a mylar.
Yeah.
So all those images, back in the days, we used to just still screen every color.
Yeah.
Put it in the oven for 15 minutes, 20 minutes, come back, put another color, but then you can't go full wrap.
Yeah.
Here, somebody else does it in a factory, puts the images onto a mylar sheet, which they can get much tighter tolerances, and then we're able just to, boom, put the whole
wrap
image
it
on
in.
one shot,
Yeah.
put it in there, and now we can go into clear coat.
Done. And how many in an hour would you do with those?
Same as paint. I mean, you see here, I'm doing about 3 seconds a shaft, load and load. So as long as somebody's here running all day, we can just pumping them out.
I would have thought it would have taken, like, from painting it and decal, I would have said, oh yeah, it's an hour to do one.
Yeah.
Well, the painted stuff's obviously got to dry.
Yeah.
So we gotta let that go in the oven.
We always say the longest part of this whole process is letting things dry.
Yeah.
You gotta let paint dry. You gotta let it sit for 20 minutes, then put it in the oven for 45 for color,
Yeah.
an hour for a clear coat. So we'll put a clear coat on top of this, and then help protect. Because like with this decal right now,
Yeah.
if you were to wipe solvent in it, it comes off.
Oh wow.
So, yeah, so if there's any mistakes on here or anything like that,
You can just go
we'll
again.
just wipe it off, put another one on. But that's why we have to put the clear coat at the end.
Right.
And depending on the product, we'll put either a glossy sheen or a
Yeah.
sheen.
Yeah, and the last step in the process is the machine right behind you. So Dre alluded to a silk screen process. It's exactly what it sounds like. We are just rolling and applying ink onto the shaft. So when you see a weight and flex, or you see a Velocor logo,
Yeah.
those are applied that way. So those are a little bit separate than the decal.
Right.
So you basically have paint as the base,
Yeah.
decal application, silkscreen is kind of the final step.
Yeah.
We clear coat the whole thing,
Job done.
ready to go.
And is that like, say, with Axiom, it doesn't really, like I've noticed with mine, they don't mark up?
Yeah.
Because of that silk screen?
Yeah, so we're going to put a
clear coat?
we're going to put a protective clear coat on it. It's the
Right.
difference in something like Axiom B, that final clear coat has a matte texture to it.
Yeah.
And something like our Ventus line, it's more kind of a sheen to it.
Yeah.
So that's just a final clear coat to protect all the graphics, all the ink, all the everything. So when you're taking that shaft in and out of your bag, hundreds of times over the life cycle of that product, you won't see any rubbing or any wear to the decal or the silk screen.
That's amazing.
Pretty cool, right?
Yeah. I actually thought, this is going to sound really stupid, I thought it was all rolled, so you'd roll the graphite bit and then there would be like a sheet that you just rolled everything on in a way.
It's not that different. Essentially, we're just rolling it vertically with a
Yeah.
heat transferred Mylar.
Yeah.
Okay, Maddie, so one of the final things that we can do that's a cool customization piece here is we can do laser etching. So we can do some customization with logos, names on shafts, just kind of a nice little custom touch. It also helps us from an R&D perspective because if we're looking at different silkscreen options, we can laser etch that on the shaft just to get a quick and dirty idea of what that looks like before we put it full the full silkscreen process. But for you, we're going to etch your logo onto this shaft, and the cool thing is, I understand you're going to do a bit of a giveaway towards the end of the year.
Yeah.
And we'll throw this laser etch logo on that piece that you give away. So everyone can see how it goes on and how it all works. We're ready to rock and roll.
Just press there and you go. Look at it, oh my gosh. It's like a 3D printer almost,
Pretty cool, isn't it? So essentially what we're doing is we're just taking a layer of the paint off and you're exposing the raw graphite underneath. And so it's really cool on the shaft that has a light color paint on top because the dark graphite really shows through.
Out.
Yeah, it makes a cool logo.
Oh wow, look at that. And you can put anything on.
Yeah.
Obviously within reason.
Within reason, yeah.
With the shape.
Yeah. This is a big part of our demo process. So when we send out our parts to our fitting facilities, we'll etch them as demo shafts, just so they know it belongs on the fitting wall and not in the retail bin. So it does serve a purpose for R&D and basically the product we ship out as well, but we can do some cool things with it also. There you have it.
The MF logo.
Pretty cool, right?
That's amazing.
Yeah.
Yeah, so make sure you're sub to both channels and someone is going to get an MF logoed shaft.
That's right.
That's brilliant.
Good stuff.
Yeah.
I'm going to show you some more.
Friday the 13th, and it is Friday the 13th. Awesome, thank you, Trey. That was
You see some more stuff?
very, very interesting.
I'll walk you through the beginning.
Yeah.
No problem.
Cheers, mate. Thank you.
Thank you very much,
Cheers.
guys. Have a good one.
So now the fun part, or more interesting part to say, after we make them,
Yeah.
we break them.
Yeah.
So after we make everything, we're going to spec check every part of it to make sure it's a complete compliance with the original design sheet. Torque has to be right, butt ODs, stiffness, everything needs to be right on jack.
Is there a tolerance, like, I know with, like, say, irons,
Yeah.
they'll have, 1 or 2 degree.
Yeah.
Is there a tolerance in shafts that you will try and work
We do,
to?
and I will also tell you that our window is super, super tight.
Yeah.
And we know that going in, and we know that that's going to increase lead time sometimes, and that can
Yeah.
increase sometimes scrap rate from a factory perspective, but we want
Yeah.
everything that we make to be as right on target as possible. So yes, there's a tolerance, but ours is very, very lean and very, very small.
Right.
This is the shaft post-grind. That's
see
where
the
you
weave in it, can't
Yeah,
you?
you can start to see the materials laid in it. So this is what it will look like when we spec it out, because this is removing any excess weight, any excess material we plan to be gone. So this is the piece we want to spec. Once we spec it, this is the exact same piece that you saw Dre in there get ready for paint. This is pretty much done. So we'll start with everything from CPMs. That's a good place to start. He's going to measure and make sure that's in line with the design sheet. We usually run it 3 times per, just to get an average.
So this is like what, flex?
Yeah, we're making sure it's within a tolerance of flex, so we can have some designated CPMs that tell us this is an R, an S, an X. These are the targets we want to hit, and we'll measure that to make sure it's good
And
to go.
how do, making a regular or a stiff, how is that differentiated in the process?
It's all based on the design sheet.
Right.
So we're going to design that shaft to be softer based on how many plies we might use or how we apply material or different designs
Right.
of material. So we can always enhanced stiffness or back it back down.
So is it like a firmer graphite or a stronger graphite that you'll
It can
roll?
be sometimes.
Yeah.
Usually if you look at a family, you'll see sort of the same ingredients, you're just altering stiffness. So if you look at Aventus, every part's got VeloCore technology, which is a blend of materials. They all have that same DNA.
Yeah.
We're just altering the amount of stiffness we have in each shaft.
Right.
So after we check CPMs, we'll check weight. We weigh them raw to make sure that they're in line exactly as we expect them to be. And then we look at this little machine right here, which is just a bend test. This is what starts to give us the idea of tip flex and butt flex.
Yeah.
So right now, you'll see this is set up with a counterweight here.
I've seen something like this before.
He'll hit the go button, and this will apply pressure and weight to the shaft and bend it.
Oh, wow.
That bend is going to spit out a numerical number, and that's what he's checking against his spec sheet. Then we'll do the exact same thing. We flip-flop the shaft. We do the same on the butt section. Press it down, gives us a number, check it against the spec sheet. If at any point any of this stuff fails,
Yeah. Scrap it.
start again.
Right. How often is that?
Pretty rare.
Is it?
Pretty rare. But the really cool thing is, because of all those checks and balances,
Yeah.
you can have a beautifully designed shaft on paper. But now we're talking about the application of that design and the application of that design at scale.
Yeah.
So this is a great litmus test for us to know, is this all going to check out? So as I said, it's very rare. It can happen though.
Yeah.
And it just causes changes in designs and tweaks.
Right.
That's all specking. Now we move into durability. So let's talk a bit about durability, Maddie. So this is a big part of what we do at Fujikura. We want our products to have a very, very long lifespan with any golfers, right? So part of what we do is we beat the shafts up as much as we possibly can. So we take an expected amount of wear for the life cycle of a shaft, and we go well beyond that to make sure it maintains its tolerance and to make sure it maintains its durability. There's two ways we do that. We do a 3-point bend test, which I'll show you. We're actually going to apply pressure to that shaft until it snaps. We have a parameter of where that pressure needs to be. Again, we go beyond that. We push, we break. And secondarily, this is kind of the fun one. You can see this is the rack shaft torture machine, and it's exactly what it sounds like. We will clamp a shaft into this. We will apply pressure just above the tip section and put a bow into the shaft. And then we will spin it at so many oscillations per second for an extended amount of time to replicate usage and wear of a shaft. So we have a parameter of where that needs to be. It has to surpass that before we say it passes our durability standards. So we were talking about quality control. This is a big, big part of it. Before we send any part to production, we have to know it checks all these boxes. So I'm going to fire this up for you just to show you. So you see that mechanism of starting to apply some bend and some pressure to the shaft. You start to see that kind of bowed angle. Once we hit that spot, that's when it'll start to spin.
Is this to replicate torque almost?
Torque, usage, everything. We're basically just trying to torture the shaft as best we possibly can so we can replicate what's going to happen over thousands of hits in the life cycle of this product. And we have golfers that have used Fujikura shafts and they said, I've been playing the same shaft since 1995. Now we like to say that we've definitely come a long way in technology since that time, but the fact that the shaft is still hanging on, that makes us feel good about what we do, that it's still maintaining all of its performance characteristics.
Wow, the speed of that spin.
Pretty cool, right?
It's amazing. I think we take for granted the shaft, don't we really? You just think, oh, it's, you know, pumped out in a factory and it just gets stuck in the golf club. Don't realise how much, you know, throughout the process it goes through and what
there's definitely a lot of steps
through.
And we're really proud of what we do and we're really proud of taking all those steps. So all that matters to us is that we get all this right on our end, and all we want the consumer to realize is that we've done our due diligence to build the best performance golf shaft that we possibly can.
Yeah. Oh.
Yahtzee. Okay, Maddie, that's sort of the start to finish how we do it. You've seen it from all the way from material sheets to paint application, testing, durability, how we roll it, how we make it, and that's what goes into making a Fujikura golf shaft.
Amazing.
Pretty cool.
Amazing, yeah.
Now for the second part of this, one of the key parts of our research and development process is our Enzo motion capture system.
Yeah.
Now once we prototype all this stuff, and we have a shaft ready to go, then we're going to send it to Andrew and Marshall. They're going to go in the Enzo studio and they're going to validate everything that we just did. So it's a multifaceted process, but I wanted to show you how we create a product before we go test a product.
So even like now it's not, the job's not done.
No, not even close.
Right, okay.
Not even close. Now, so after this, we'll have to go through Enzo testing and validation. We'll go through player test. If it's going to be a tour part, we'll go through PGA Tour player testing, and then we're getting closer to launch. So all this has to start from a conversation about what we want to see, to a design sheet, to motion capture, to player testing, to production.
Amazing.
Takes some time.
Right, let's go and see this Enzo then.
Cool.
So we've seen how the shafts are made now in the factory, from beginning, coming out of the fridge, all the way to actually being a graphite shaft. But now we're going to find out why they were made, so why that profile sheet, that spec sheet, is what it is. We're going to do that and take a look at something pretty cool that Fujikura have here on site in Carlsbad. Andrew, how are we?
I'm doing good.
So we've seen the shafts being made now, but what we want to understand is why they were made like that.
Yeah.
Spencer talked a lot about a spec sheet that you'll run through, a profile sheet. You obviously build shafts for different needs, different players.
Correct.
And how do we go about that?
It all starts here with Enzo and our player testing.
Yeah.
And so Enzo is a 10 camera 3D high motion capture system.
And that's these?
Yeah. All 10 cameras here. They all have the ability to run about 2200 frames per second, but we don't because our server room would probably just
Set on
explode.
fire.
Exactly. And so to not do that, we run them all at about 871 frames, which is still quite ridiculous.
Yeah.
But what we're doing is it's essentially an MRI for a golf shaft. And so with launch monitors, we look at what happens after impact.
Yeah.
What we wanted to see was everything that happens before that.
Okay.
Everything from how a shaft bends, twists, deflects, droops, leads, lags, and we get all that measurement in inches, millimeters, miles per hour, degrees, everything like that. And
all
so
from this.
all from this. And so, you know, it's a similar system to what 3D animation uses. So like for video games, so maybe like FIFA,
Right, okay.
you get players coming in doing their signature celebrations.
Yeah.
They get dotted up with all these
Oh, yeah, like
on their
when you see
face.
the green suit and the
exactly.
little balls
Yeah.
over
Yeah.
it.
And so that's what we have here. These little sensors that will get picked up by those cameras. And so by positioning them in certain spots, obviously we'll have them on the head as well, they're not on this one, and slowing it down to 870 frames per second, we can see exactly how a player loads a shaft,
Yeah.
how that specific profile and what those materials in those specific places do, and how they react going into impact. And we, started obviously with woods, and now we're starting to do with irons, which is really, really exciting.
Amazing. And this is sort of the stuff that
Yeah. So this
sticks
is
out then.
yeah. So Enzo started about 12 years ago. What we really looked at was, okay, how does the bending profile of a shaft affect ball flight?
Yeah.
Right. And so we realized that by changing the bending stiffness in different areas of the shaft, we could change launch characteristics. And that's how we got to the Atmos line. Right. So Atmos, all the handles are the same, so that you have a linear, similar feel from your driver 3-wood to 5-wood. But we changed the bending stiffness in the midsections and the tip sections to affect ball flight. So, our black, Atmos Tour Spec Black, had an extremely stable, stiff tip. And so that's going to bring the ball flight lower, versus the red has a softer mid and tip section, which helps create more dynamic loft into impact and get that ball up in the air. And so from there, we're like, okay, we know a shaft doesn't just bend, we know it also twists.
Yeah.
We realized, okay, what if we put a material full length on a bias sheet, meaning it's at plus or minus 45 degrees, and we make it ultra premium, really stiff, really light. What does that do? And we realized that when we did that at impact, on specifically miss hits, the face didn't twist as much.
Right.
And so on off-center hits, say off the toe and off the heel, we were getting better dispersion, better ball speeds. And ultimately, even on center face contact, which is what we really want, we're getting faster speeds as well.
So you would get a shaft that's come from the workshop at the back.
Correct.
Dot it up.
Yep.
See how it performs here. And you can see what's going on, and then if something needs changing, you can then feed that back to the guys
to our engineers,
and then they'll alter and just make another shaft, go through that process. So you're really able to fine tune everything. It doesn't have to go out to the player.
Correct.
Come back for their feedback. Go back again. I would imagine you're saving weeks, if not months.
Yeah. So the cool thing is we use data analytics to analyze all this in a system, and so what all these shafts here on the wall are actually kind of a massive gauntlet of different weights, flexes, torques, materials. And so like you see with TR, we have that spread toe material here put in different places. And so we have it here in the mid to tip section. Here is about the same. This one specifically is mostly that tip section. This is that mid section again. This is just longer from almost that mid section all the way down to the tip. And then we have a short tip flag just right there. And so what we're doing when we have consumers come in and hit that is we're creating bookends. And so these are wild configurations we would never do in an actual part. By the time enough players have gone through that test, our engineers using data analytics realize, okay, this is what that material does. This is how it affects different characteristics in different areas. They know where the optimal spot is for the goal we're trying to achieve. And so we realized with TR, and specifically with blue, that mid-handle section was where most players were feeling that kind of chatter.
Yeah.
And so we knew that by moving that material in that area, by seeing it stiffen up in the other areas and how it's reacted, we already knew where it was. And so our prototypes that we rolled out, instead of rolling 15 to 16 out and taking 6 months, maybe 9 months, maybe even a year, we only have 2 to 3 prototypes. And the one thing that Enzo doesn't tell us is feel. Right? We get all these numbers, and so that's specifically what we do when we do player testing. And we're the only shaft company that has a full-time consumer testing role to specifically just
get
dial
feedback.
and feel. Yeah,
so
correct.
you can see what the shaft's doing from a data standpoint, alter it, get a bit of feel and feedback from a punter, and then we've got the product ready to go.
Yeah, and so ultimately, you know, as much as we want something to work as best as possible on paper, at the end of the day, the player needs the confidence to make it actually deliver. And so having something that feels phenomenal is something that we really pride ourselves in, and that it also, you know, works on paper and on Enzo as well.
Yeah, and you've got a new shaft coming out that's going to be out soon. How many iterations did that go through?
You know, our engineers are pretty good, and so it's not many. We do get pretty picky though when we see certain things that we missed our goal maybe a little bit. We'll go back to the drawing board and just try it again, but it's usually not more than 3 iterations in player testing.
Wow.
A lot of times it might be a quick change in durability testing, just like very fast, but for the most part, we're not spending more than maybe a month at the very, very most on one part.
That's amazing.
Yeah.
Absolutely amazing.
And so, I mean, we've
That is Enzo.
Yep. And the cool thing is, I mean, we got the camera here for a little eye candy, and it's running at, you know, a really, really nice slow-mo speed. We can get to our 3D view here, and we can see exactly what the shaft is doing in 3D space. And so, I mean, it is really, really cool what we can see. We can just kind of be a fly on the wall, go around the room, and see exactly what the shaft is doing. But then, of course, the meat and potatoes is right here in all these measurements.
Yeah.
So we've got max handle speed, max shaft deflection, so that's how many inches you're actually loading the shaft.
Yeah.
And so here, this player's 3.14 inches. So at load and transition, that shaft is deflecting 3.14 inches. And we've actually, through testing, been able to find out what is actually optimal. And we found it's about 3.2 to 3.5 inches is pretty optimal.
How many data points would it collect?
In terms of these, we've got max shaft deflection, lead, lag in inches. We've got the droop and the drift of the shaft in inches as well. How much the shaft is twisting open in degrees. And so another cool thing is we take that player's head, if we have a tour player come in, and we'll measure the bulge roll, the MOI, the CG, loft, lie, everything like that. And we input that into the system, and so the shaft or the club head is no longer a factor. And so now we can take that out completely and see exactly what the shaft is contributing by itself outside of the head. And so here we see that this shaft specifically is adding 4.3 degrees of loft. It's changing the lie 6.6 degrees toe down, and for head face alignment, it's shutting it 1.4 degrees. Naturally now people are gonna say, well, so if I slice the ball, if I'm over the top, or power fade, power cut, is there a shaft that naturally draws the ball? We can see that here, that there's specific designs
that will help,
that can help shut
the face a little bit more.
But obviously that's a tough area because of how players deliver it differently, or a draw to one player might be different than a draw for another player. Yeah. And so if we rolled one-offs for everyone, I think there'd be a line all the way down the street, and I don't think any of us would be able to get anything done. But it's a cool idea. It's something that's possible, and maybe in the future we go away from all our weights and flexes, and it's just okay. I want to hit this shot. Boom. Boom. This is the shaft. Yeah.
That's amazing.
So that's kind of what the 30,000 feet capability of Enzo.
And there's only 4 of these in the world?
Three. So we have one here. Yeah. Fujikura Japan has one. Yeah. And then Ping has one. They use theirs a little bit more for club head. Correct.
Yeah. Amazing. I'll get one in the studio.
Yeah. One in your garage for you.
Brilliant. Well, thank you for taking us through that. That's incredible what you can see, really, all from a few dots, it feels like.
Yep, and so we know exactly what a club is going to do at impact and how it changes with different players and how they load it. And you'll hear me talk about it over and over again. It's very important how a player loads the shaft, and that's why we are very adamant on getting fit, and we're having different profiles that are specifically engineered to change those launch characteristics and to kind of cater to those kind of swings.
Yeah, interesting stuff. So we found out how the shafts are made, and we found out why they're made like that, and then ultimately this is what we are left with. All these different types of graphite shafts. For me, I'm astounded at how complex the actual process was and how much goes into it. I think I very much thought that it was rolled from one piece of graphite, was rolled into a tube, and they threw some stickers onto it. It's a little bit naive, I think, in that thinking, but I think it's amazing then how much they are able to profile the shafts and go through with Enzo, a process that gives the exact parameters they want from a shaft. And then also the cool stuff like being able to put the laser etching on it and all the different decals is pretty cool. And also remember, if you do want to win that laser MF etch shaft, you've got to subscribe to our channel, you've got to be subscribed to Fuji's channel, and we'll be giving that away very soon. Guys, I hope you've enjoyed that tour, something different from us today, just to show you actually what goes into making some of the products that we all use. Thanks for watching, and I'll see you in another video very soon.